Sorry, I forgot the recording at the beginning. Oh, it started recording. So this is show you how to move the sample, right? And let me switch back to the use interface. So you see it, and also in the stage here, you can double click anywhere. See, I want to double click here. You're gonna move to the position you just double clicked. And so once you move to the position, you can also move back. If you save a position, you can always move it back. See, I just saved this position too, because I know this is the position where the silicon is. I can go choose here and say go. It's gonna go back to the sample position. It's quite convenient. So once you find a sample, it's always recommended to add a sample position. For example, I want to add. This is a new position, so you can name it. You say silicon 2, and then you push, click this icon here. It's gonna say yes or no. Yes. Then you change the name of the position. And if you click here, it's gonna this is flap out that you come to do. You can reset your holder. You can only reset X and Y. You can also reset only reset alpha and beta 2. And here is do wobbling for adjust the usage high in the TM mode. And this is a fine. You can save the position. Again, you can save your stage position wherever you want. You can click save at, choose the location you want to save. And once you save, you can open a file. So you can say yes. So open the file you just saved. And also you can do set. Set means you want to go wherever you want. You know, sometimes I'm going to show you a very useful function here. So for example, I took an image. I go to this is the image I took yesterday in there. So this is a Velox processing, data processing. If I do right click, publish, I got the sample position. Like it says position X, Y, Z, and also give you tilde, alpha and tilde value and beta tilde value. You can copy this value or you can write down this value, and you can go stage, flap out, put the value here. It's gonna go to the same position. Let's just do a quick example here. It's 187, 326, like 187, 326. How about Z? Z is negative 147. And beta tilde 1.67. 1.67. Beta tilde negative 0.67. Negative 0.67. You can say, okay, go to. It's gonna go to this sample position. This sample is STO, which is Johnsonian, titanium, and oxygen. So and then we go to the light. I'm sorry. I choose the light acquisition. It's moving. It takes some time. Did I say go? Yeah, it's frozen a little bit. Anyway, it's oh, we got an arrow in B value. Okay, maybe this value is same. Okay. Yeah, so it's just now because the value we're typing, maybe I'm not type it wrong. I think I type it degree. Okay. Then we move to this sample, which is STO. The location, I just take the high resolution image on this sample. So this is the way. So we find the sample. So from the stage, we can. This is how we set the stage, right? It's useful because usually if you use the copper gray, you can if you move the rest of the you can only set the one value. Like if you want to only go to the I want to keep the rest of the values the same, but I want to move to this Z to the 100 micron here or negative 100 micron. You can just type a value here and say go to. It's gonna only move you Z to minus 100. You can see so from bottom right, you can see you can get a live view of your sample position. So you can see read the X value and the Y value and the Z value, alpha tilt and the beta tilt, and the screen current. Here, okay. The next tab here is the setting. So the setting here, you can store position. You can go to direction, choose different option here. And sometimes if you see enable is grayed out, it means you have a problem with your folder. You can simply, usually you can disable it and enable it again. It's going to solve the problem. But if not, you probably need to contact service engineer to do so, to fix the problem. Yeah, and what else? So this is the stage. Is there any question about the stage?
No.
I can show you also a good function to show is Vlog software. So if this is a live view, right?
A quick question: are you also going to show me how to do it in TIA?
Yes. Okay. I'm going to show you. First, I'm going to go through all the interface, and again, I'm going to show you how to do stem alignment, and then I'm going to show you how to do the stem imaging with TA software, and the next how to do the imaging with the Vlog software. So but mostly we're going to use the Vlog software because this is a newer version of image software. It's much better compared to the TA software, I think, in my opinion. So this is another function I'm going to show you here, how to move your sample. So for example, here, I want to move to different location, right? I just double click. In any view, it's going to move the sample. For example, I want to move this sample to this position, move sender to this position. I just double click anywhere. I double click this position. It's going to move this position to the center. So this is a new function in our Vlog software. So it's very convenient. So usually we use the stage to move your sample to the close to the region of interest, and then we use the we just use the Velox, double click the region of interest to move the region of interest to the center. Okay. Okay. Yeah. Let's move to the. Let's go back to the silicon sample. So, because this is a sample we use it for the low mag and the high mag imaging today. Okay, we go back to silicon device sample, and you say this is very convenient. So so I think the first step is we need to find a sample. The most thing we need to do is to use stage to move sample to the close region what's interesting, and then we can use the acquisition software of Velox to center the region of interest. Okay, and then below that below stage we have direct alignment for alignment probe, to do probe alignment, to do TM alignment, and then we have different apertures. We have condensed aperture 1. We can have usually we choose 2000. So usually we leave it at 2000. So we don't choose a smaller value here. For the normal imaging, STEM imaging, TM imaging, just keep this a default value 2000. For the condenser 2, we can choose different value. So for the alignment, to better see the rankigram, we use 150. So during the imaging, we have used 17. So if you want to do the convergent beam diffraction, we might use the 50 or even 20. So also, if you want to do the narrow beam diffraction, we want to choose 20. So I'm gonna introduce more detail later. We also have objective aperture, so which give you different choice as well. So this is for enhance the contrast of your image. We mainly use the objective lens aperture in the TEM mode. We don't use in STEM mode. So we also have select aperture function. Yeah, we can insert select aperture for diffraction imaging. So we have different sizes to choose. Okay, so the next window, sub window is camera. So the camera we have. Let me minimize that. So the camera, this is for CCD theta camera. This is for TM imaging. So I'm gonna introduce more on this when we do the diffraction training. And also we have an image setting. We can reset shift, which are different to shift the image. This is also for TEM imaging. Also, we have aperture choice here. We have beam setting, which lets you choose different probe mode and also different spot size. So you can choose. So for STEM image, definitely you need to choose nano probe mode. Unless you want to do nano diffraction, we probably choose micro probe. If you're interested, I can show you how to do nano diffraction. Also, we have freedom to choose different spot size, so we can go down spot size to 1, 2, 3 different value. So for the low mag STEM imaging, we usually choose the 7. Let's go to 7. So this gives you when you change the spot size, it's going to normalize the lens, and it take a little bit of time. So you see the current increased, right? You screen current. Do you see here? Do you see here? So what's the current value? If you go back to 9, so it's gonna decrease to 49 or something. Yeah, so right now you notice the beam is not at the center. In this situation, we can use diffraction environment to move it to the center. Just click differential alignment here, select it, and then you can use the hand panel multifunction X and multifunction Y. Let me zoom into hand panel so you can get a more clear view. Panel. You can use multifunction X, multifunction Y. So this is the button here that you choose find or cost. If you click close, you can increase the step. And if you click find, you can decrease your step. So, and then you can use X, you see your center, your beam is moving around X direction. You can use Y, move beam to the around Y direction. So just move the center deflection disc to the center. Okay, and then you can see, once you're okay with that, you can see down. Okay, this is the beam setting. You can, when we use the spot side 9, we get a beam current 44 picoin. So, and this is for usually spot side 9 for high resolution TM imaging. So today we're gonna do just normal STEM imaging. We want a better contrast. So we want a more current. More current means we have more signal goes into our detector, and we have a better contrast in our imaging. So to do that, we can just change the spot size. We can go to spot size 7 or 6. 7. We can go spot size 7, and you can increase the spot size 7 means you have a bigger spot. So although the value, the spot size number is decreased, but your spot is increased. Spot size is increased. So this is the improportional relationship. So just notice that. So you see your current increased to almost 200.
Can you swap the screen for me?
Oh, sure. Sorry. Yeah. So you see your current is increased to be 200. So just be careful. If you have a beam sensitive sample, you might want to choose the smaller beam current. So in that case, you can keep the spot size number here, but you can decrease your gun increase your gun length. In that case, you can also decrease your beam current here, just as you know. So we just use the gun length 3 for low map imaging. So it just depends on your application. If you have a very beam sensitive sample, you might want to keep your current to below 0.1 nanoangstrom, nano N. So yeah, I will give you more detail later. So, but just give you basic idea the how interface look like, and this is the stem. Because next sub window is stem. So this is the main window we're going to use for stem imaging. So because right now we are doing live view, you still putting your beam on the sample center. Your beam current is very large. It's going to damage your sample. So in that case, we can break the beam. If we don't do imaging, we can just break the beam. So and also we have a different view. We can do search, preview, acquisition. This is a imaging focus. You can choose your scan size here. You can choose your different focus. So you can use the intensity for focus. You can use the objective. Intensity to do focus means if you look at the hand panel here, this is intensity lob. So it means we use if you change the intensity lob, we're going to change the focus. If you choose objective, if you see here, so this is focus. If you change this one, you're going to change focus. So So that means if you change focus, it's gonna change objective value. If you change the if you choose this one, when you change the focus, it's only going to change the intensity of your beam. It's not going to change the objective stigmate. So usually we leave this intensity, and also we have stem detector here. We can choose different detector. We can choose different camera lens. So right now you see it's grayed out because we use a relax for imaging. So that's the reason it's grayed out. So if we switch control to the TA, it's gonna give you option to if you select this one, it's gonna give you option. It's gonna to deselect the detector. You see this one become yellow. You can choose different camera lens here. So, and then you have different contracts. You can choose the contracts. You can use the multifunction knob. If you look at the hand panel, you can choose multifunction X and Y to change the contracts here. And here let you select different detector. Right now, bright field DF4, DF2 rejected. So we only use the hot F. So calibration, we don't have the option to do so. So you don't need to do so. Usually, service engineer gonna take care of that. So direct element. So this is for if you right now we're at you see right now we're at the diffraction mode. We see the central disk of your diffraction. So if you do direct element, we want to go take a look at the beam directly. If you look at the hand panel, let me switch the hand panel. So this is diffraction. You see this red line, then it indicate we're in the diffraction mode. If you want to go out of the diffraction mode to take a look at your actual probe, this is right now we're in a micro probe. So if we go out of that, we click that, this red line goes off, and then we switch to the normal mode to see we can, in this case, we can see how a probe look like. So usually it's you take a look at the magnification. Let's switch back to the using the camera. If you took a look at the diffraction, take a look at this magnification here. It's at highest mag. So if you want to see your probe, you need to lower the magnification. You see your probe here? So in this case, we can align the probe by use the different direct alignments. Simply, first thing we need to move. You can move to beam to the center. So, and then if you go back to the diffraction mode, you can just click diffraction. It's gonna go back to diffraction again. So we just need to rank the beam. Okay, this is diffraction alignment. I'm gonna give you more detailed introduction when we go through the step-by-step guide. So this is just for introduce you to the interface of our TM alignment and the imaging software. So the next window is Stigmator. So this is the most tool we use for get HR scan imaging. So if you select one of them, it gives you value. You can always right click. It gives you option to reset to 0, and also you can copy. So you see this is 3 column here. You can copy column value in the column 2 to 1. You can copy value 2 to 1. So this is good because when you start to you can use the multifunction X, multifunction Y to change the value. But once you change the value, if you feel you want to go back to the initial value, you can just click because you save the position, copy the value 2 to 1. You can just select the value in the. You just click the value in the column 1. and then you can bring the estimation value back to the initial value. So I'm going to show you more later. So just a quick view of that. Okay, the next tab is low dose. Low dose is for time imaging. So we're not going to cover today, and we're not going to cover in this training. So maybe next training. So we're going to go through that when we do diffraction training. So because this training is for STEM and EDX, so we're going to skip that. So and with them, we have Corium. In the Corium, we have beam setting as well, dark field imaging, stickmeter. And in analysis, we got the SuperX server. So we SuperX server, I'm going to I'll give you more detail in day 3 when we do EDX training. So this is experiment when you choose different spectrum correction. So when you do narrow diffraction mapping, you want to do you probably need to use this experiment function to do so. I can show you how to do that when we do diffraction imaging, diffraction training. Yeah. Okay. Others, we got a microscopy test. So this is a test you point resolution information limit just measuring all this. It's when you choose one of them, it's going to give you step-by-step guide. So and then you click start, it's going to show you how to do it. You just follow that. And the magnification calibration is that you calibrate your diffraction by using the cost rating, gold sample, and by calibrate the high HR stem on the stem imaging by use the silicon 100 sample. So let's have different options. So usually, when you select one of them, it's gonna give you step-by-step guide. Calibration system, you can calibrate system and calibrate camera and application. Usually leave that for a service engineer. So, and the crystal pack, this is for diffraction. So we're gonna skip that. And the stage, this is stage advanced setting. So you can have piezo stage. So when you enable piezo stage, you can, for example, when this is for high resolution time imaging or STEM imaging. When you enable piezo control, you only you can do very fine control of your stage. So with minimum drifting in a sample. So you can just move. You can use if you enable here, it's gonna let you just enable. You just click enable, and then it takes some time to enable that. And once enable, and you can do move. You can move step size to 1% for 1%. So the maximum range you can move is probably 2 micron. So once you reach the maximum value, you need to do reset. So let me show example here. So this is I can use the cross. You see, you can use 10% because this is a low mag. I need to go to the high mag to use this function. So this is pretty high mag. You can cross. You see, sample is moving X direction. You can cross. You can adjust like 10%. This is to show you the range, how much you move according to the max range. The maximum range is 100%. When you reach the 100%, you cannot move You cannot move with the piezo stage anymore. Let's reach the 100%. You see, when you reach the 88% become red. That means if you move further, it's going to reach the maximum value. In that case, you cannot move with piezo stage anymore. You need to reset that. So once you reset, you're free to move on again. So this X direction, you can also move Y direction. So also you can use joke. Joke means you can move stage in the one direction. When you push the joke, you can move like say, hey, I can adjust let's say 5%. Okay. It's jogging around the X direction. So you can say it's move this value constant change. It's change right now is 1.2%. You can select how you increment here. Maybe increase a little bit. Right now it's a little bit too slow. So this function is pretty useful when you do in situ TM experiment. So when you say you have a constant drifting around one direction, then you can set up the jogging in another direction to compensate that drifting. For example, if you have a drifting around X direction, a positive X direction, you can set up the velocity so increment in the negative direction. So, and once you feel you're okay, you want to stop, you can stop anytime by just click stop. It's going to stop jogging. Okay, this is piezo control. You can reset as Y. It's going to reset to your piezo, put you to 0. Okay, so auto tuning is for stem, is for TM. So when you click start, it give you a step-by-step guide. So I'm gonna cover that doing over deflection training. Okay, the next one, this is for use. This is for use. So do you guys have use on your system?
I don't think so.
Okay, then we probably just skip that. So you can, so in the bottom right corner right now is you can see right now it says long. You can click drop down menu. You choose one of the several icon. We can just say flag control. We can say thing setting, right? And stage control, it's give you a little bit sub window here to control your stage. So you don't need to go over here. You can also go over here to choose the stage, but also you have ability to choose the stage from here. So you can choose stage piezo fab out here, and you can customize your interface, workspace interface. You can go here. So as I mentioned, when you go to vacuum here, we have vacuum first, fab control photo, and we have high tension, and I have back register, we have aperture. So you can customize your interface. So for example, I go stage. This is my second sub window here. So I click here. I say right now I have a stage, direct alignment, aperture, right? So I can just switch the sequence between stigmator and aperture. You see right now I'm saying stigmator instead of aperture, right? And then swope that again. I can see the aperture, right? So you can also add something. So here's from here, you can have a lot of options to add in. So you can click expert. So you see, um, it has different account, right? You have a user account, expert account, supervisor, and service account. Don't add service stuff into the workspace for the user. So usually you just add the, some function in the workspace under the user. So for example, here I want to add like, let's add um, vacuum, for example. Just put it here. So, and then move to the above the, you see, this is your vacuum here, right? So of course I don't want to put a vacuum here. I just, if you can jog into to the right to remove it. Now you remove your vacuum view. Okay, so you can customize any type of window you want. Okay. And more. So the bottom gives you view about, give you live view about your magnification and the beam current, and the mode is done, and your high tension value, spot size, number, focus step, objective length value, and C2 length value, and also your converge angle. So 10.5 is the most, it's converge angle we use usually when we choose. You can, when we select different aperture, we might have different converge angle here. So for example, if you choose the 50, this converge angle tends to 7.5. So smaller stage aperture, smaller means you have a smaller converge angle. Converge angle, it's when you do STEM, high resolution STEM imaging, you want a higher converge angle, right? But if you choose the 70 is, if you choose the 450, you have a highest converge angle, but you have a lot of aberration. Good, because you actually choose too large. It's you have a lot of aberration. It's hard to adjust in the Talos system. So in this case, we need to choose the 70. In this case, we limited the aberration by choose the smaller aperture. At the same time, we have a good converge angle to form a good HR STEM imaging. So also, this is your diffraction length value, coding, theta cam, and dose rate here. You can defocus value, and this gives you position with your sample. You can right click to add value to your to this window. So you can say you want to right now I want to those three. You can choose different okay. You can add a spot size, add one more spot size. You can see here, you see, this is spot size we just add. So, but right now we already have spot size. We probably want to remove that. So, so by click anywhere, right click anywhere, you can, for those three, you can choose different unit. You can choose electron, nanometer, square per second. You can choose the angstrom. You can choose different unit here. So yeah, also from the right here, right panel here. Sorry, let me make it right. Yeah, you can just because we already have spot sign, you can just drop to the out of the window to remove it. You can just quickly stop sign and jump out of the window to move anywhere you want to place this sample window. Okay. Yeah. This is
How did you remove it?
just select them. For
Mhm.
example, I want to remove the spot sign, right? I just select and just click that, hold it, hold the left click of you on your mouse, and move. You see, move out of window, and then drop it. It's gonna go. You get
Okay.
it? Yeah.
Yeah.
Just select icon, and then hold left click and move out of window and then drop, and it's gonna go. So you can select that because spot size is important. We can bring it back, and we probably we have two dose rates. So just move on then. Okay. Okay. So under this is the last window. I know it's a little bit small. Let me go to the lower left zone. You see better? So this is lower left corner. You see it's give you different option for multifunction Y, multifunction X, and multifunction Y, which right now is being shifted and then being shifted Y. And it's a shortcut for you for the button on your hand panel. So right now, because let me show you hand panel. Hand panel here. So this is a shortcut, right? L1, R1, L2, R2, L3, R3. So and so this left corner tells you what is L1 related to, what is R2 related to, R1 related to. R1 right now is screen lift. If you push the R1 in your hand panel, it's gonna lift the screen for you. L1 is right now is assigned the alpha wobbler. R2 is assigned a beam blank. L2 is assigned normalized all lengths. R3 is assigned spot size plus. R3 is assigned spot size decreased spot size. So right now joystick is here. This the joystick. It's assigned the stage moving. So you can customize this shortcut button by right click here. You say you say I want to do. You click L2. You select L2 and then right click. You say L2 is for you can assign any value here. You say I want to do reset focus for L2, or you want to do anywhere. Let's say whatever icon you want to. It's your preference. So yeah, this is how you customize the value. So this so usually for me, I like to set I usually set L1 is for the alpha wobble. It's very useful when you do adjust the using to height in the time mode. And R2 as R1, I usually set the screen lift. It's for lift your screen for taking TM imaging. L2, I usually set the normalized all lens. Usually when you go to the high magnification and then you go back to low magnification, you adjust you change your lens value. You might want to normalize the residual magnetic field in your lens. Residual magnetic field in your lens. If you don't do so, it's going to affect your image a little bit. So that's the reason we usually set L2 is normalized all lens. You push L2, it's going to normalize your the magnetic field in your lens. So R3, L3 is for like spot size, decreased spot size or increased spot size. If you push L3, it's gonna decrease your spot size to 6, right? It goes R3 it's gonna increase your spot size back to 7. So this is just shortcut. Okay, last thing I think I'm gonna keep introduce you the hand panel. So this is the hand panel. From left to the right, we have 2 panels. They're separate. So we usually put them together. From left to right, from left we have alpha tilt and beta tilt. Alpha tilt, which is the X tilt. Beta tilt is Y tilt. You tilt the holder, basically you tilt the holder like this. This is beta tilt. X tilt is around X direction. So we also have beam shift visible. You can shift your beam to image shift, or you can shift your beam. When you shift, you see the sample is moving a little bit. This is the image shift. You don't actually move your stage. You move your beam. So this is a button for change the step size of how fast you want to move your beam. And also we got an intensity lock here. We have fun, have cost. So in the TM intensity, it's change your intensity of beam. In the stand, if you change the intensity, you change your focus of your image. Also, we got the stigmator. This is shortcut. If you click that, you see yeah. If you click stigmator, you see this is a quick. It's a window pops up. Give you option to tune the stigmator. If you decide, it's gone. Okay, now we have the multifunction X and Y. So multifunction, we can adjust different value by multifunction X and Y. This is the reason we limit multifunction. This can do multiple things. We can adjust beam shift through this function. We can adjust center the C2 aperture through this function. We can do diffraction elements through this function. So when you're in the direct element, here we can just select one of them, and then we can use the multifunction to adjust the value. Okay, let's go back hand panel again. So this is the L1, R1, L2, L2, L3, R3. You can note the value from the left corner. You can customize the shortcut of this button. So as I mentioned to you just now. And then we have magnification locked here. You can change the magnification. You can zoom in or zoom out. Okay, so for the magnification, the smaller the magnification in the normal stand we can do is 5,000. When you keep going, if you do counterclockwise, it's zoom out. If you do clockwise rotation, it's zoom in. So, but if you keep to counterclockwise, you found the smaller the magnification 5,000 in the conventional stand mode, in the normal stand mode. So if you want to see smaller magnification, you probably in the stand here we need to enable low magnification. Yeah, if you click here, if you don't click here, if you uncheck this.
Can you switch screens so I could see the?
Oh, sorry. It's always confused. Yeah. So if you go to the stand tabular, if you go to you can select enable low magnification scan, and then you can keep going. You can go to First, if you keep to counterclockwise, the first you're going to experience very hardest magnification in the low magnification in the LM stem. If you go here, you see LM stem. Indicates right now we're in low magnification stem mode. The first magnification is 1.15 million. So this is the highest magnification in the low magnification stem. And you can notice that your objective lens is almost shut off. So that's the reason. So we in the low magnification scan, we almost shut off our objective lens. So if you want to do high magnification, if you keep counterclockwise, do counterclockwise, you're gonna reach this. You can go the small magnification. You can do a 280. So it's about 200. So as I mentioned, you shut off your objective lens. Don't if you want to do high magnification stem, don't keep your mode in the low magnification stem for a long time, because you basically shut off your objective lens. If you go back to the normal stem mode, you have to retune your alignment, because when you bring your power in your objective lens back, when the power of your objective lens back, you have to retune the alignment basically. So that's, as I mentioned, for Talos system, we have constant power the objective lens. When we switch between stem and TM, we don't need to do so much tuning, because the objective lens is constant powered. But if we switch to the low mag stem, so we have very small low mag objective lens value. It's still on, but it's almost shut off. So then when we go back to the normal stem mode, if we want to do high magnification, probably we wanted to spend a little bit more time to do the alignment. Just keep that in mind, because if you, I would suggest, because a lot of people use the low mag stem for finding sample, because they found it's give you a large field of view to locate a sample. But if you keep in the low mag stem for a long time, it's probably affect your alignment. So I would suggest usually we use this TMO. Low mag, we can go small mag in a TMO to choose to keep objective lens on. We find your sample and then switch back to the normal stem mode to do imaging. So in that case, you still keep your constant power lens on. You don't need to do so much tuning. Okay. Any question?
How long is too long in?
Usually keep for like a half day. You know.
Oh, so if you use it for like one session or something for too long, then you have to retune.
So for example, now if I go back, you see the focus doesn't change much. The stick probably is okay. So it's still okay. So if you like, I would say if you're crazy about the resolution, you want to take a good HR stem as good as possible. I would suggest you, once you find the region of sample interest first in TEM mode, and then switch to the stem mode, do the HR stem. Don't go back to the low mag. Don't go to the low mag stem. In that case, it's gonna take some time for you to get the best HR stem imaging. So that's as you see, when we may go back to the normal stem mode, you see the objective lens value, it's go back to 94%. It's almost right. So think about, because when we partially shut off objective lens, we change the value, we change the magnetic field, and when we bring it back, definitely that's we need to do tune the speed measure. So yeah, okay. So just
so I see that the enable low mag scan is still on the check mark. You have to uncheck it.
Yes. So if you keep, it's fine if you don't use the magnification to go to the. Right now we are still at the STEM mode, right? If you enable this low mag scan, we can use the magnification to go to the low mag scan. If you uncheck that, we cannot go to the low mag scan. The lowest magnification is 5,000.
Oh, so it just limits the magnification, right?
It just limited magnification.
So as long as we go back to the right mag, and the objective is on, we'll be okay.
Yeah, you're
okay.
right.
Okay, thank you.
Yeah. So yeah, that's magnification. Okay, let's continue talk on the hand panel. So focus. So the focus lobe is different from the rest of the lobe. So it have basically two rings. The inner ring is adjust focus value, right? When you do counterclockwise, it's gonna decrease the focus value. When we do clockwise, it's gonna increase the focus value. So the outer ring is adjust the focus step. So you can hear the clip sound when you adjust the focus step. So let me switch back to the user interface. So look at here, focus step. Focus step. Right now, this focus step is 5. So I can use look at my hand. I can use this outer ring to adjust the focus step. Okay. Usually when we do high magnification imaging, we usually use the focus step 1. When we do low mag, we probably use 3. So, and then you can use the inner ring to change the focus. You see, this is a defocus value here, shows here. When you do counterclockwise, you're gonna go to a negative value. When you go clockwise, it's gonna increase your defocus value. Okay, we're good. Okay, so I think, and then we have the wobbler. Wobbler is basically you can turn on the wobbler to wobble your stage to make sure you find the right U-center height. And also we have U-center focus. So when we go, if you go crazy about defocus value, like you go several micron defocus, you wanna go back to the U-center focus. You just click U-center focus. You go back to default U-center focus value. It's gonna go back to default value, which is 0. Okay, this. Okay.
So a quick question on the focus.
Mm-hmm.
I remember you said earlier it was the focus knob changes the intensity.
Yes, yes. Right now the focus, you can go stem, flap out, focus. Right now, the focus.
Is that only for stem? Is that set for stem?
Sorry, what do you think?
It's set for stem mode?
Yeah, that's for stem mode.
Okay, and then normal TEM, it's usually just the objective lens, right?
Yes, yes.
Okay, I just want to clarify.
Yeah.
Thanks.
You can choose that. Actually, you can choose if you choose the focus objective. Right now, your focus lock change the objective lens value. If you go, you see the if you change the focus value here, you go negative 17, right? Right now it's negative 77, and you see your objective lens here, the value is changed. You see here, when I change the focus, your objective lens value change, right?
Okay.
But if you choose the intensity, when I change the focus, you see the focus value change, objective lens value keeps the same, but you see two lens value change.
Okay.
Okay. So intensity is related to the C2 lens. Objective is related to the objective lens. So you usually leave it, you can do intensity and objective. So in this way, when you adjust intensity lock, when in the focus, we just choose the intensity and objective. That means when we use the focus lock here, we change the diffraction value or objective length value. When we use the intensity here, my left hand, intensity, this one change the C2 value.
Okay.
So when you change that, you can always go back, say you change your focus. It's gonna go back to 0. Okay, so to make sense on sample, I just usually choose the intensity. So this is useful for center your C2 aperture. So when we center your C2 aperture, some people, I'm gonna show you later. Some people just in the focus, they tend to use the objective, right, for focus, and then usually we center C2 aperture, we go over focus and under focus. We want to make sure our beam is wobble concentrically, right? So, but when you have focus, when you choose focus as objective, so when you change the focus, under focus, over focus, you change your objective length value. You're not changing your C2 length value. In this case, you cannot judge whether your C2 is centered or not by seeing being wobbling concentrically. I will show you later. You will see more detail when we do that element. So let's change it back to the intensity. Okay, I guess I'm done with the introduction on the first software, which is TM user interface. I think next I'm gonna spend a little bit of time to introduce the VLOG software. So again, we have our acquisition software VLOGs here, and also if you go, you can choose the processing. This is the data processing software. So two different interface. So because right now I'm not imaging, I'm not doing imaging. I just bring the beam. So okay, so this is you can bring the beam through the TA software, or you can bring a beam use the VLOG software. If you click the view here, you can bring a beam here. Okay, let's just keep it on. So this is a beam marker. Just where your probe, data probe locate, you can just put not on the sample. That means it's not going to damage the sample because we put it on the vacuum. So let's go from 5. So this is acquisition. So usually we set up the preference here. Go the second. If you select edit and choose preference, it will give you option to choose your auto save path. So here I set use fader UCM training, and you can select you can choose the experiment name. I'm not set date. You can select the date and the name. Here I just choose the experiment name second device. Today we're gonna look at the camera lens effect. So you can add the you can add the label here, say camera lens effect. So I'm gonna summarize the camera lens effects, take some image, and you can share with the user to let them know how the camera lens affect the image quality and the image contrast. Okay, so and then once you feel okay with it, you can also select the different name. You can, if you include the probe mode into the name, you just click the right arrow. It's going to go to the select label, and this is going to display on the file name in the file name. So if you're going to unselect them, one of them, you just say select them, and then click the left arrow. We're gonna deselect this label. So you can choose the order, say up, down, right? This is the order of the label. Also, this will give you option to choose whether you want to save partial results or not. So because when we do scan, so sometimes because your stage can take some time. So during the scan, you might stop it, then you get a partial result. So if you uncheck that, it's gonna save the partial result. So here I don't want to save the partial results, so just check that. So say do not save partial results. You can always restore default setting by simply click this button here. If I click restore default, it will go back to default path and the date default setting. So and then we need to go back to experiment name, choose the path, and go back to document. My configurator, the server, this folder, name, Merced device, select the folder. Okay, and just you can define experiment name, or just say silicon, and you can name the label, camera lens. Effects, and you can we can define we definitely need a date. Acquisition type, no, I don't need acquisition type. Typically, we select the date first, time, magnification, and yeah, that's all. And then we say OK. Then we set up the file saving path. So when we take an image, the image is going to automatically save that in that path. Okay, then we have view here. We can choose single or different view, single, horizontal. You can just right now we only have one window, so just choose a single. And optics, right now we are in stand mode, we're diffraction, nano probe mode. Tell your status, your camera lens, magnification. You can choose any magnification here. You can just go 10,000. This is very convenient here. You can choose whatever magnification. This is a shortcut. So you don't need to turn the knob to choose the magnification. You can choose the magnification by just simple click here. And also you can choose your camera lens here. Right now it's 205. And you can go to 98. You can go to anyone you like. So we go back to 200. This is the most case we use. Also, DBC is for differential phase context. So we're gonna leave it right now. Detector is so it's gonna let you select, because right now we're in stand mode. We're not gonna use data. Help give you some option to see the to see some instruction from Velux menu. You can just select one of them. You're gonna pop up the menu, so it's give you detailed instruction on how to use the Velux software. So we can just say this is a Velux menu. So it's got a lot of page, so it gives you all the stuff. So if you can just select some of them to share with the user. So it's and then behind this this option, we have layout, we have object. It's kind of a shortcut. So you can switch between temp and the stand, can add some annotation, add some text, draw some line here, right? So you can do, you can just use your keyboards, just delay. That's annotation. You can type any text, of course. This is for select region of interest, spectrum image for select region of interest. So if you do so, you want to take image first. You need to stop the view first. So stop the view. And then this is spectrum region. So this is your EDX mapping region. So we're gonna do more detailed introduction in day 3, and this is for drift correction. It's a drift correction error. It's gonna do the cross-correlated drift correction. So I'm gonna give you more detailed instruction in day 3, on day 3. And then this give you option to select different detector. If you click this is recheck hardif, you click again, gonna insert hardif again. So this is DF4, and you can select DF4, insert DF4 detector, and you can insert DF2, you can insert bright view. So here give you layout of detector. So you see, right now we have bright view, hardif, and dark view all insert. So here give you live information about the collection angle of different detector. So this value, this collection angle is the angle between the beam and your detector. So for hardif, it's because it's annual, it's got inner ring and outer ring. So the smallest angle is related to the inner angle, collection angle between the inner ring and the central beam. The highest angle, collection angle, which is 172, is related to the collection angle between outer ring and the central electron beam. So so this will give you how. So the value of collection angle give you the information what contrast you have in your imaging. So for hardif right now, the collection angle is basically larger than 28. So that means most contrast is from Z contrast. But if you have very small collection angle, that means you get electron into bright detector, then your contrast is most from the different contrast. So right now you don't see the signal to the other detector because we don't leave the screen. Because the hardif detector is above the sample, or other 3 detector is below the sample. So in order to see the signal from the other 3 detector, we need to leave the screen. We can either use the hand panel to push the R1 button here. We can also click the main screen here. This is the main screen. If you click main screen, it's gonna leave the screen. So now we get the signal to the all 4 detectors. Okay. So and you can choose the camera lens by choose the value here, and you can define the field of view. Field of view is magnification related. So you can choose any. It's basically you change your field of view, you change your magnification. So you can go higher magnification. This is the 700 nanometer field of view. This is the 2 micron field of view. Okay, you can type any value you like. So you want to type 2.2 micron here, and you can say enter. It adjusts to 2.2. So in a stand, we are free to choose any field of view. This is different compared to the stand mode. The stand mode, you can only select a certain magnification. You cannot choose your field of view. So, but stand, you can type any value in your field of view. I mean, as long as not exceed the maximum. The maximum value probably is about because again, it's 5,000, right? The field of view about 24.3 micron. Because this is the lowest magnification we can go in the low conventional stand mode. Okay, so and then we got a different scan notation here. We got we can rotate imaging. It's just by cross means you can cross choose different value. You can rotate your sample. Just quick sample, quick cross or minor. Also, you can if you put your mouse hover on the value here, you see left and the right arrow. If you do left click and hold it, and it jerk in one direction, it's gonna let you change the value. Just hold the left click and move left and right to change the value. So if you want to sample perfectly parallel to one direction, you can use the function here. Just click this button, and then you select the direction you wanted to do parallel, and then you draw the arrow from left and right to make sure it's parallel the certain feature of your sample, and that sample is aligned. You can parallel this section. Go back. Or you can, anytime you can type any value here, go back to 0. This is a low rotation, right? This is 0 image rotation. So, and then you can say, I want to parallel this direction, which make it look nicer. Okay. This is just give you a quick view. This is 90, rotate 90 degree left. This is reset rotation to 0. This is rotate right 90 degree. Okay, this is give you option blanket bin. This is focus error, give you reduced error if you click this button. It give you small. If you zoom in, it give you small area for the focusing. Right, you can change your focus. You use your focus up here. Use this small window to do focusing. This window have this window have much higher refresh rate compared to the large window. If you're done with that, you just click that small window again. It's gonna go, and then you click live view. You get the nicely focused image. Okay. Then we can do stem imaging. This is the option give you to set up the live view setting and the view for acquired imaging, and also some. You can also take series or take a video. So so this is I will go through that when we go through the step-by-step guide. Also, we have the EDX option. give you live view, give you choose different setting, and choose the exposure time, energy range. The max is 80 heavy. You can bring it in when parts, when idle, and you can choose different exposure time, and you can choose SI image. You can choose the mapping time, mapping dwell time, mapping size, mapping frames, how many frames you're gonna overlap, and you can choose drift computation, something like that. So we're gonna go through the when we do EDX mapping. Okay, finally we reached the right panel. Right panel, we got display setting page one. This lets you control the stigma, control the contracts, range. You can just this item lets you go back to the you're gonna automatically adjust the contracts for you if you click this one. If you click this one, if you hover your mouse over there, it's gonna tell you what this icon does. So this is boost the display intensity to make the image look more vibrant. If you go here, it's gonna basically a little bit give you more contracts. So, and this is the inward contract. You go here, you black turns to white turns to black. Okay. Oh, this is FFT pattern. So we're not going to use this in the low magnification stem, but we're going to use this for HR stem imaging. We're going to do more detailed instruction tomorrow. Okay, we got an objective purpose function. It's that tells you image size, pixel size, field of view, and intensity, mini intensity, max intensity, duration, dwell time. If you draw a line here, it probably give you the property of the line. It give you value, length, how many pixels we have in this line, and the angle of the line. Right? It began with where it began, where it end. Okay. If you do that, it's gonna you can select different window for that. Okay. This is detector layout. It gives you live view of the detector, and you see your being it goes through. This is the sample location. It goes through the sample. We have hydrogen detector, DF4, DF2, body field. Above sample, we have 4 silicon drift detector. Recorder is suplex. This is how many counts we got from different detector, EDX detector. We have 4 of them. So right now it's off, so we don't get any count from them. Okay, here it's the option to insert the camera. Right now it's not insert because we're in stem mode. But we can insert the camera in stem mode to take some nano detection in stem mode. This is detect setting, so it's you put scope on. It's select scope 2. It's gonna let you select adjust the offsets and the gain. So the offset is brightness, the gain is contrast. So usually for the HADF detector, the default value is 42.5. So just keep it. You can type this value here, 42.5 set. Right. This is a if your detector is normal, this value is not going to change much. But you can adjust your gain. So by using scope tool, but now you see the curves, you can give a little bit more contrast. This is this contrast is over too much contrast, so we can decrease a little bit. To make sure this, you see this green line is below the red dash line, and above the blue dash line. So we don't want to overexposure, but we want enough exposure to see to get a good contrast. So if you go below the blue line, you don't have good contrast. If you go over the red dash line, you're gonna overexpose your image. Okay, and you can do auto. You can click auto. It's gonna automatically set for you. But usually we do it manually. But see you can select different window. You can select the DF4, which is good. It's between the blue line and the red dash line. This yeah, you can adjust the contrast. Just make sure the green line in between red dash line and the blue dash line. Okay. I think that's all of them for interface. Any questions so far?
No questions. So okay. VLOX is we always have that, right? Because I'm just familiar with the TIA. That's all.
Yeah. So I think VLOX is a new version of image software. It's very powerful. It's give you a lot of options. For example, in TA, you're not gonna able to see the detect layout, right? And no, you're not gonna have freedom to adjust field of view. So a lot of new function we add into VLOX. You can set you can use this rotation tool, and also the choose thing is we can do data processing use VLOX. So we have a lot of a filter we can use for filter off the background noise. We can do FFT. We can do process. See in the imaging. We can a lot of things we can do. So, but for TA we don't have because we don't develop new function for that for imaging. Now our focus is to develop new function in the VLOX. So almost every 3 months, we have a new function. We have a new version of the VLOX. We have a new function to add to the VLOX. So yeah, I think this software is very user friendly. So here I can introduce a little bit more the data processing window for the VLOX. So file here, you can open a file, you can view file, you can process data, you can do EDX, see with the EDX setting. Here, you can choose different camera, you can do have off pause, you can for the TA, we don't have data so much. We don't have good data EDX visualization and quantification. But in VLOX, we designed to have a good quantification or visualization function. We can do the most important function we have in the VLOX processing is quantification EDX data, the visualization EDX data. I'm gonna show you this way. So yeah, this is the most This is our new version software. And the most important, do you guys have DF4 detector?
Yeah.
Oh, okay.
I looked at. I think we're pretty sure we have DF4 and DF2.
Okay, great. Then another very important function is differential phase contrast imaging. So if you have DF4, you can do you can image in the magnetic field and the electric field in your sample by using the DPC function. So basic DPC use DF4 detector. So if you have DF4, I can do a little bit more introduction on that. So after we finish HR scan imaging, EDX image acquisition and quantification. If you have more time, I'm going to introduce you DPC function in our Relux software. That's if you don't have time this time, but we're going to leave it for the next time training. So I have made a very detailed step-by-step instruction. I can share that material with you definitely. So after the training, I will create a box link with all the materials in there, and also I'm gonna include in some imaging we take in this training for you to share with the user as well. Like today, we're gonna take a look at the camera lens effects. We're gonna take imaging with different detector at different camera lens to see how the camera lens affect the context of imaging. So, because this is very important to show to the user. Because some people they have hard to take image by the dark field, DF4 image. If they use very large camera lens, they probably get bright field contrast. So yeah, that's yeah. So yeah, this and this. So I think this this morning we have to go through the presentation to give you a concept, a step-by-step kind, and also we go through different image software, introduce you how to load the sample to the holder, and also go through all the interface, all the Windows step icons in their TA software, and also go through the user interface of Relux software. So I think the next is to show you how to do scan imaging step by step, use the TA software, and then use the Relux software. And then after that, we're gonna take a look at the camera lens effects on the different contracts. So yeah. So so what time now? Now it's do you prefer to take a lunch break right now, or you wanna do later?
Let's do a lunch break now. Then we could do this stuff. Yeah, we can have a lunch now.
Okay, yeah. Let's so let's back 1:30.
What? 1:30?
Yeah, 1:30. Is that okay? Yeah. So I need to drive home and take lunch, and
All
then back at 1:30, and then we can go through all the imaging by using the TA and Relux. So yeah, sounds good.
Yep.
Okay.